Now let's start with the second part of this session. Actually, this session will be speaking about how to create something called the nest area or even creative grids, in other words, or in other words, we can call it how to make clustering or even sampling or binning. What it means by all of this? Actually, first, let me tell you one thing that we will here merge or go through practical examples from many of the things we have learned in the previous two sessions in this particular exercise. So for example, assume now you have this kind of points in the map, these points representing, as you can see in the bottom left here, that each point representing a particular speed or test, like assuming that this is being tested done in the network with data being provided and it's randomly in random locations. And each point is representing a speed. For example, the red colors representing and orange representing speed from 0.1 till 5.7. And this blue color representing 28 up to 265 as an example. So the data we can see it here in this particular area, for example, visualization point of view, it's not representing, I cannot identify which kind of areas having a low speed or better speed or which areas need optimization. So actually, in this case, we can go for the grass part in order to create something called, for example, a study area. So where we can need to have this kind of sampling and data collection, where the grass can assist in systematically sampling or collecting data across the study area. So we can create small clusters here to be able to visualize and to be able to identify the worst areas in terms of speed and so on. And this is also can be, for example, very useful in term of data comparison. For example, if you like if you did any changes and you would like to compare between different days, so in this case you will have your cluster already fixed, and any points within these clusters can be aggregated, and this is also one of the function of the grids and other function we are going to explain. For example, if you create small cluster, let me show an example what we are going to reach into. For example, you have this called join layer. If you look into this, this is will be how the final figure will be looked into, that we can create a grids or hexagons as shown here with any size. Like for example, 100 by 100 meters, 150 meters. This one is showing 100 by 150 by 150 meters, and you can see each hexagon is representing a particular speed. For example, the red one from 0.2 till 2.8. Any sample falling within this kind of hexagons, you can take the aggregation of these samples and you can identify the aggregation, whether you take the mean, the maximum, or whatever. So here, visualization point of view is very easy now to identify the best areas and weaker areas. For example, here I know that this red things, it's having very low speed where I need to look into. So now let's start to explain from scratch how we can create that. And as I mentioned to you, it will be very, very useful to have a practical examples about many of the things which being explained in the previous two sessions. So now let's start from scratch now. So now here we're going to start. So now I have uploaded my data sets into a new template where we're going to start from scratch. But I just uploaded this kind of points and I just make a categorization just to see the colors of each and every single point. So first, let's explore the data which you have to have more understanding about what kind of data sets we're going to work with. So right click, open attribute table, and this is where what we have here. For example, here you have each and every single point here in the map is representing a test, like downlink speed, downlink and uplink speed test here, and this is being done in different days, as you can see, for example, 8, 10, 11, 12, and so on and so forth. Okay, and here even representing the technology which is being done for this particular test. So now we need from this kind of data to reach into this kind, creating a small grids or hexagons where we can identify the best and the areas which require optimization required to take it into the next level where you can start like finding the worst or outliers area where it need to be tuned or optimized, as we mentioned. So the first part you would like to do actually, as you recall, the first part here, you just let's zoom in here in this particular area. So in this part, I would like to create a polygon to cover this area. If you remember, the thing you need to do, you just can go from layer. If you remember from the session, then you will create layer. Then we go for this new temporary scratch layer. Okay. Then let's call it, for example, clusters. Clusters. Then the geometry for that part, it will be as polygons as we did before. Then we can just do here, call it, for example, name of the polygon in case if you need multiple polygons. But at the end, we'll just create only one. So now let's click OK. So now we have something. Now we need to enable the toggle editing in the top left here, as we mentioned before. Now we just need to go here, add polygon feature. Then we can just manually start drawing our polygons. We can just manually. So yeah. So I just completed the polygon creation around this area. So actually, this is the first step. Now we would like to have a grids with you between this, define the grids, customize based on your reference, what kind of size you would like to define, to just try to calculate our points which being falling within here. So now we need to use a tool in this processing toolbox, which is called grids, create grids. So if you search into create grids, for example, you'll find it under vector creation. There is something called create grids. Now let's look into this one. If you double click here, then here you will find this kind of parameters. First part, it's asking you what kind of grid type you would like to create. Here, this is a grid type. This can be any of those types. For example, hexagon, diamonds, rectangle, line, or whatever you need. So in this example, I'm going to use hexagon, which are representing a polygons. Now it's asking you what kind of grid extent you would like. So usually we do this manually, or even you can take the map. We already explained something similar to this before. So I'll just click here in this arrow. I will just draw on map canvas, as you can see here. Then I will do like that here, and I'll just select, for example, this particular area. Here it's giving the coordinates of this area. Now, the most important part here, which is actually require a good focus for this part, is asking you about the horizontal spacing and vertical spacing. This usually, if you want to define in meters, you need to change your coordinate system. Let me explain this part. First, read this kind of here, this part, is saying that distance in the geographic degree, consider your project in the project local coordinates for accurate results. Here is telling you that currently your project is working in geographic degree. Actually, this geographic degree is my current system, which I'm being used here, is called EPSG 4326, and this is actually known as WGS 84, and this is a geographic coordinate system that uses for both latitude and longitude. This is our project coordinates. So it's not using like meters and so on, in meters or units. So in this case, you need to change this kind of thing. So you can even change the complete project, or you can just go from here. This EBS 43, the WGS 84, you need just to change it from select your CRS. This is coordinate reference system. So you just click here. Here it will ask you about what kind of format or coordinates you would like, coordinate reference system you would like to use. Let me explain to you. You have two different types of coordinate system. The first one, which you already explained, which is called, we usually call it this WGS 84. And you have another something called UTM, for example, the WGS UTM zone or UTM. This UTM actually, it's like a projected coordinate system that you use units are typically the units are typically used or measured in meters, and it divides our Earth in general into zones. And U2M usually is very well suited for this. Any require like any area or task that require accurate measurement of distance or area within a specific region, for an example. So now, for example, this area here, which I'm showing you, is located in Saudi Arabia. So I would like to find what kind of my coordinate system in terms of UTM, what I'm using. I know it's 37N. I will explain how I got this, and I will explain how you get it for different area. For example, this 37N is referencing for Jeddah. This 30S, for example, is referencing for Malaga. I will explain to you how you can this kind of things. You can identify from Google Earth. And this is very important to locate, whenever you do a project, to locate the correct UTM system to give you an accurate result. So for now, I'll use this 37N, which is representing my kind. So I'll just select this one, and I'll go back here. Select this one, and I will go back. Now here, change it to BGS. See, now you can see now the units changed it into meters. Now it's fine. So now I would like to create it, for example, 150 meters and by 150 meters, as you can see here. Then I will run it. Okay, now let's close it. If you look into the background here, in the background here you have many hexagon rides being created. Even if you zoom in, and you try, for example, to check now from the top here, the measures, like what kind of the line or distance we have it in this area. So for example, let's select and see how much we have. If you look into bottom right here, we have in the bottom right, it was having 150 meters, as you can see in the bottom right here. So let's here, take it here just to be more clear for you. So I click, for example, here. See, it's showing like 150 meters. So this is actually representing whatever we have created. Now let me jump to the Google Earth just to explain how you can get this UTM system whenever you do this accelerator, which is very important. Now I'm opening the Google Earth as you can see here. Now I just quickly would like to know, for example, what is the Malaga UTM, which I'm going to use. Let's search for Malaga and jump into Malaga and let's see what will. Okay, now in this Malaga, if you look into, for example, select any single points here. If you look into that part and just, for example, take it here or anywhere, just make OK. Now our coordinate system, if you go to tools option, is based on decimal degree, right? So this is not representing the UTM. Okay, the UTM is called universal transfers. This is where you need to know in order to get it. If you just click it OK for now, and then you click apply, then OK. Then here, you just click again in any points in the map, which you have it in this location. Right click, properties, for example. Then you will like here. This is now your, it's saying easting, northing, and this is like representing in meters. But your zone now is 30. But you need to know what is the Earth hemisphere in this part. So how you to do that? Just go to the view. So you can look into the longitude. If, for example, your longitude in a negative value, this means you are in the south. This means your area will be 30 south or 30. If it's the longitude in positive value, so it will be the zone, and positive values representing something called north. So, for example, it would be 30N. So this is now I identified, for example, for Malaga, it's 30S. This is the same which I have done for the previous area, which I mean dividing as called 37N. So now let's go back to and continue with our working. So now going back to the map, let's load again the points which you have it here inside this one. So we have this kind of points, and if you remember, we already created the polygon. So now I would like to have this hexagons only within this particular area, and then within where the points our points is being falling inside. And here where we need to use another tool, if you remember, it was called select by location. If you can recall it, this select by location, it was on the top right here. This was in the previous second section, where second section or second session where we explain it. This select by location, if you click it here, this one, select by location, and this is under the selection toolbar here, this one, you click here. So now this one is saying, okay, which feature you would like to select. For example, I would like to select based on the bigger cluster, right? So let's select the bigger cluster, which is called the grid. I will just select this one, and you would like to compare it with which feature, for example. So I would like to compare it with the small polygon which have been created, which is called the clusters. This one, the yellow one inside. So, for example, clusters. Then I would like to select the intersect between both of them. So if I run it, I'm expecting that this inside the polygons or the hexagons will be only highlighted within this area. So let's run it and see what will. See, very good. See now, it's just highlighting anything from this polygon intersect with the hexagons or the grids is being highlighted now inside here. If you hide this one for now and even hide the points, see now this is the selected area which is being created now inside this kind of grid. So now let's export this selected area, the one we would like to work. For example, we have our points being falling inside this one. So let's export it to have it as a permanent layer and also to use it as itself. So whenever you go for the export, remember to save selected feature as. So just select this yellow part here. So just click here, save selected feature as. Then, for example, let's save it here. We call it, for example, selected area. I'll just give it the same name which we have it here. Then I will click OK. It's asking me to override. Yes, I would like to override this file. So now it's being created. So if I highlight this one, now it's being showing our selected area, which used by the select file by location or select by location. Yes. The next part, if you look into this point, now we need to calculate, right? For example, within each hexagon, what is the average speed which we have it? So we need to make like this kind of calculation, like to have this kind of to join the attributes, for example, to join this hexagon with the points we're going inside. And here where we have another tool in the processing toolbox, coin called join attribute by location summary. If you look into this part, join attribute by location summary. This is giving you a benefit to having a join between different layers, and you can even give it based on attribute or a field, and you can give even a metric or a calculation method. Let's double click and see. So you are double clicking here, then you have this kind of join attribute. Then which feature you would like to join? I would like to select this selected area, right? Which is already being saved. Again, we use this same function called intersect. I need to compare it with what? I need to compare it with the points, right? Where we need to calculate the speed. So here you have it. Then you have the downlink speed here. And under the downlink speed, now which field or you would like to summarize using which one? So if I click the three dots now, it will be showing my table information, which I need to summarize, for example, by any metric. For now, I'm using by downlink speed, correct? Then I'll go back. Then it's here, it's giving downlink speed. Now it's asking you which summarize to calculate. So if I click here, it will just give you, for example, here some calculation method. For example, the count of the samples, the minimum, maximum, average, whatever you need. So I'll be using mean, for example, here. Then I'll go back. Then here you can just discard records which couldn't be joined. For example, any records falling outside. So just click this one in case. Then you can run it. Then let's see what we have got. Let's hide this one. So now we have this kind called join layer. Now let's try to do one exercise. We have already, this is the final image. Even if you compare, you'll find that some of the hexagons is not being, for example, here, this particular one is not showing anything. Because if you look into the points, you will not find any points falling inside. Here, for example, there is no points. That's why it didn't create, it's reduced even more for our hexagon. For example, this hexagon also is not here because there is no points falling inside. So now let's try to categorize it by color to identify the areas where it's having a low speed. So what we need to do, the same, which you have done before, double click, then you will have this information under the symbology again. You have the single symbol, right? Then under the single symbol, you can use categorize or you can use graduated. The difference is between both of them, the graduated can give you control over the range that you would like to do. So I will use graduated one. And here, for example, you can have a color ramp. So I will use, for example, this color ramp, which is spectrum from red till green or till blue, which I'm telling them I need to see the low speed as red color and high speed as blue color, for example, or green color. I can change that this part. Then here, the value, right? We need to do it based on what? Based on the speed, right? Which is mean, right? This is our calculation. Then you do classify. See, now it's giving you different ranges. Here, even you can increase it more. You can make it based on 7. Here it's increasing. And you can even do manual change here. You can do whatever range you would like to double click. Then you can just give manual. You can just give any manual ranges you would like to do or react to. And here also you can do some changing in the colors. For example, assume I don't need a blue. I need, for example, a dark green. For example, here, for example, this part. So I will change this one to dark green as an example. So here we go. So now let's apply and see what we'll get. Okay. Now here it's showing here. Let's just take this in the layers above. Let's take it in the top of the Google Earth layer. See now this is how it looks like. So this is, if you look here, this is mean the small hexagons. This is showing a very low values, for example, 0.9 to 4.1. And it's also the green one showing that the dark green is showing that this is having high speed. So this is, you can identify easily your areas and you can control the hexagons based on any grids. For example, 20 by 20 meters, 10 by 20 meters. So this is based on your requirement. You can just do this kind of things. The last part I would like to explain to you, for example, the same exercise can be done, which can also be very useful in case if you would like to have facilitating your data comparison. Assuming if you look into my original data sets, which is called downlink speed, this original one, if I go open attribute table, for example, in the last column here, you find something called benchmark or PM. This is having pre and post, okay? So for example, this means I have some testing being done in pre and post where I take an actions and I would like to compare now the pre and post results. So in the initial, which we have it as a single point, it was not comparable because the points was being randomly. But it's if you create it already has a hexagon like that, in this case, you can create the same exercise which I explained through filtering first your data, for example, for this downlink speed. For example, you go filter here, then you go to the benchmark sample, for example, then you give here, as we explained before, double click here, then you make OK. Then, for example, you filter this one as pre, then you make OK. Then you can just, for example, here, so this my data this is my pre data. So now I can again repeat the same steps which being explained, create hexagon for this one, then I can duplicate this one and make a new one, filter again. Then in this filtering, you can now again change this one, for example, to post the below bottom value. If you confirm this one, you just benchmark sample. So you have only be here because we are just filtering this one. Let's test it. So now it's working. So even this one now, it will be falling in different locations in the map. It's just showing down here. That's why it's not showing the results. I'll just take it up in the layers. So for example, here we have this different location sample. So it will be even now more easy for you to, after you create two different hexagons, you can now calculate the delta between both of them through, if you remember also one of the methods we explained it before, through this properties, right click here or left click, then you have this kind of join field, so you can join both hexagons based on, for example, the or any other thing. So you can create the delta, so you can even having to identify which area being improved or degraded and whatever. So this is also one of the use cases, very useful use cases, especially for the benchmarking point of view. And this is will make it more easy for visualization.